So on your handout, which I hope you printed, but maybe you didn't, we have examples of percentile scores versus SAT composite scores. They're a couple years old. You can get these online if you hunt for them. Examples of percentile rank for various SAT scores are given. It's on this sheet here. Can you see what I'm doing? Yeah, it's that one there. From the tables, it can be read off that an individual who scores 1250. So 1250 is at the bottom of one range and the top of another. And the percentile score for that value is 81. So from tables, we can read off that an individual who scores 1250 scores at or above 81% of those taking the SAT. True enough. So a pretty decent score, 1250. You can look up your score there if you want. Of course, I don't know about what kinds of scores we accept anymore, but I'm sure 1250 is probably good enough. I'm not sure how it works. We do use SAT as a discriminator, but of course with COVID, we may not be collecting SAT scores this coming semester. So that's the end of percentile rank. That's my example. Not too exciting. And then we're working our way down the list that happened on the previous slide. Percentiles, now quartiles. We're going to find the quartiles. Here's how you do it. So you have a data set, and you want to find the quartiles. Place the data in order. I use a stem plot. Find the median position. We don't need a stem plot for that. It's n plus 1 over 2. The quartiles are the medians of the values above and below the median position. We'll see how that works in a second. So here's two examples. Here's one when n is 10. Those are the values. There's the stem plot. N plus 1 over 2 is 5.5. So above and below, uh, 5.5. So we'll just count up to 5. 1, 2, 3, 4, 5. So there's 5.5, 6, 7, 8, 9, 10. So we'll take the ones below 5.5 and the ones above 5.5. And now the medians are the quartiles. So there's 1, 2, 3, 4, 5 values above that position. Each has size 5. So n plus 1 over 2 for that is 3. But you would guess with 5, you go to the third one. Third from the bottom, third from the top, and then do it again over here, going up 1, 2, 3, going down 1, 2, 3. So there's 74. Q3 is 74, and Q1, oh, I got it upside down, sorry. Q3 is the big one. Q3 is 91, and Q1 is 74. Okay, so here n is 9. So n plus 1 over 2 is 5. So the quartiles are the medians, the values above and below the median position. So the median position is number 5. So we would have selected to find the median. 1, 2, going down. 1, 2, 3, 4, 5. There it is. Going up. 1, 2, 3, 4, 5. There it is. So we're not going to use that value in computing the quartiles. Now we're here. Those values, and we're also using these to there. And we're finding the medians. Medians of 4 values is at position 5 over 2, 2.5. So we're going to average 2 and 3. So the second and third. Second and third here. So upstairs, 83 plus 88 over 2. Sorry, that's the small number. Upstairs, 102 plus 95 over 2. Q3 is 105 plus 95 over 2, which I get 98.5. And Q1 is 83 plus 88. $85.5. So let me write this down because I might need these later. So for the first data set, Q3 was 91 and Q1 was 74. And the second time around, that's with 54. The second time around, Q1 85.5 and Q3 98.5. Okay. So we're going to use these quartile values to determine if there's any outliers in those data sets. So what I'm going to do is I'm going to erase everything. I'll just leave the data sets up there. I should leave this. We actually need the stem plots. I'm just going to, everything except the stem plots will probably be all I leave when we get back. Figure out how to find the outliers here, and then we'll do it over here. That should be fine. And I'm just setting off this one now.